What is the most powerful natural disaster that humans have ever experienced? Is it a tsunami like the one that hit Indonesia in 2004 or the 2011 Tohoku earthquake and resulting tsunami in Japan, which together took over 250,000 lives and caused more than $230 billion in damages? Or maybe it's Hurricane Katrina in 2005, which devastated New Orleans and left more than 1 million people homeless and caused more than $125 billion in damages. Those are certainly horrific, but they are tiny compared to the Carrington event, a solar storm that occurred back in 1859. In this video, we're going to tell you what the Carrington event was, why it was so dangerous, how it affected life on Earth, and what would happen if something like it were to happen again today. You won't want to miss this. Before we start, make sure to subscribe so you don't miss out on any of our videos. So what exactly was the Carrington event? Named for English astronomer Richard Carrington, the Carrington event was a massive solar storm that occurred on September 6th and 7th, 1859. Today, scientists believe that the event was caused by a coronal mass ejection, or CME, an immense burst of plasma and magnetic field that occurs when the sun's corona releases a huge amount of its atmosphere into space. CMEs are often, but not always, caused by solar flares, regions on the sun that appear darker than their surroundings. When these cool areas expand and then pop, they release bursts of plasma. Richard Carrington was making what he thought was an ordinary sketch of sunspots when he noticed a flash of bright light coming from the sun. He later wrote, "I turned to my desk and made a hurried note of the circumstances and walked out to the observatory to see if I could find it through the telescope. On looking at the sun through a telescope with a rather narrow band of red light in the middle, I saw at once a large flare which had not been there in the preceding sketch." Carrington's assistant Richard Hodgson saw the same thing and the two recorded the event. But neither of them knew just how significant what they had witnessed really was until 2 days later when, while reading the local newspaper, they learned that telegraph systems across the world were sending messages without being connected to power. We'll talk more about that in just a minute. First, let's take a look at what happened as a result of the Carrington event. Auroras were seen all over the globe during the storm, something that doesn't normally happen because the northern and southern lights only occur near the Earth's magnetic poles. In fact, on the morning of September 7th, 1859, auroras were spotted as far south as Mexico and Cuba. The lights were so bright that many people mistook them for the sun. One observer reported seeing a bright, beautiful aurora about 3:30 in the morning, which continued till daylight, causing a most intense glare over the whole heavens, even in the daytime. It was impossible to see distinctly the figures of men, animals, or objects, all being confused together in a white blur. The solar storm also had an effect on telegraphs. Electric shocks were reported all over the world, and some telegraphs even worked without being connected to power. One telegraph operator in Pittsburgh wrote, "About 10 o'clock last night, I observed the magnetic needle of my repeater, which is under the floor, vibrating very fast and erratically. I stopped my battery, expecting it was going the last. When lo, the letters passed without electricity." Even more dramatically, a telegraph operator in New York sent a message to his counterpart in Pittsburgh without electricity. He simply tapped out a message using Morse code, and the letters appeared on the receiving end as if by magic. That's because the geomagnetic storm created by the Carrington event interfered with the Earth's magnetic field, inducing electric currents in telegraph lines that allowed them to function without power. Now imagine what would happen if something like this were to happen today. First off, the electric grids and transformers that supply power to our homes and businesses would be severely damaged. Power outages could last for weeks or even months, especially since repairing equipment would be difficult due to damage to communication systems. Satellites would be knocked out of commission, GPS systems would fail, and communications would be thrown into chaos. There would be massive damage to electronics and computer systems, not to mention the danger posed by exploding transformers and other electrical equipment. And these are just the direct effects. The indirect effects would be just as bad. With no power, there would be no refrigeration, air conditioning, or heat. Water treatment plants wouldn't be able to function, meaning that people would not have access to clean water, Grocery stores would quickly be emptied out and there would be widespread gridlock as people tried to go about their daily lives without cars or public transportation. Hospitals would struggle to operate without electricity, putting countless lives at risk. In short, society as we know it would cease to function. But the good news is that it probably won't happen anytime soon. According to a study published in the journal Nature in 2013, the Carrington-class solar superstorms happen about every 500 years, with smaller storms occurring roughly every 50 years. So we're pretty safe, right? Well, maybe not. Some scientists believe that the sun is entering a new active period, which means that we could be in for a bigger than normal solar storm in the near future. And even though the odds of a Carrington-level event happening in our lifetime are probably pretty small, the consequences would be so devastating that it's worth being prepared. And speaking of preparation, let's talk about how much a Carrington-level event would cost the U.S. economy. A study published in the journal Geophysical Research Letters in 2013 estimated that the direct cost of such an event would be between $774 billion and $2.65 trillion. This would be due to the need to repair damaged infrastructure, replace lost equipment, and compensate those who lost their jobs due to the economic fallout. In addition to the direct costs, there would also be indirect costs. For example, the agricultural industry would suffer major losses due to spoiled food and other damages. The fishing industry would also take a big hit as fish stocks declined. In all, the total cost of a Carrington-level event would likely be in the tens of trillions of dollars. And if you think that's bad, just wait until you hear about the deadliest volcanic eruption in history, which we'll talk about in an upcoming video. So make sure to subscribe so you don't miss it. One of the scariest things about the Carrington event is that it could have happened much more recently. Up until the 1950s, scientists believed that the Earth was protected from solar storms by a magnetic shield. They didn't realize that the sun was capable of sending plasma and magnetic field directly toward the Earth and knocking our planet's magnetic field out of whack. But that's exactly what happened during the Carrington event. And it could happen again. Even though the Carrington event occurred in 1859, it wasn't officially recognized until 1921. That's because at the time there was no such thing as a space weather forecasting system. In fact, the first space weather forecast wasn't issued until 1959, 10 years after the launch of Sputnik, the first artificial satellite. Since then, we've come a long way in our ability to monitor the sun and predict solar activity. But the truth is, we're still not 100% sure how the sun works. And that means that we can't say for sure how often a Carrington-level event will happen. What we do know is that they happen more frequently than we used to think. According to a study published in the journal Science in 2016, evidence of recent Carrington-level events has been found in ice cores from Greenland. The researchers analyzed ice cores dating back 700 years and found that 3 of them contained unusually high levels of beryllium-10, an isotope of beryllium that is produced when cosmic rays collide with the Earth's atmosphere. The researchers believe that the beryllium-10 spike in the ice cores is evidence of 3 Carrington-level events that occurred in the years 1470, 1544, and 1621. This suggests that these events may happen more frequently than the 500-year timescale previously thought. In fact, some experts believe that we're overdue for one. The last Carrington-level event that has been definitively linked to the sun was in 1859. If the 500-year timescale is correct, then we should have experienced one in either 1959 or 2009. The fact that we haven't had one in the past 60 years could mean that we're in for a big solar storm sooner rather than later. Some scientists believe that we entered a new solar maximum in December of 2019, which means that we're entering a period of increased solar activity. This could increase the chances of a Carrington-level event occurring within our lifetime. And even if it doesn't, it still could happen sooner than we think. And if you think this is scary, just wait until you hear about what would happen if a rogue planet the size of Jupiter suddenly appeared in the inner solar system. So, what do you think? Would you rather experience a Carrington-level solar storm or a giant rogue planet? Let us know in the comments below. And don't forget to subscribe so you don't miss any of our videos. See you next time.